Hello, ladies and gentlemen. We are going to be talking now about proving triangles congruent. We talked about this when we did our triangle shortcut theorems in that magenta foldable, but now we're going to be formally writing proofs when we're saying that triangles are congruent given those theorems or postulates. So now that we have a good grip on how to write a two-column proof or a more formal proof, and since we've practiced with our algebra and we know all of our triangle congruent shortcuts like side angle side, side side side, all those different things, I'm just going to give you two helpful hints. So recall when writing proofs and using properties or just definitions to justify what you were saying. So first helpful hint is know your triangle shortcuts. These are your end goals in proving triangle congruence. And then two, mark your picture with congruent marks as you write things or justifications in your proofs. Those are my two helpful hints for today. So this brings us to our first example. So if you need to pause the video and write everything down and pretty please with the cherry on top, draw the picture. The picture is what will help us when you look back into your notes and look at these proofs. And then also when you're writing down and pausing the video, write the given and the proven statement. So just like we did with our algebraic proofs, we are going to write two columns, our statement and our reasons or justifications. If you want to write justifications, that's perfectly fine. And then if you want to draw the two columns themselves, you can go right ahead. So our first step, as always in any kind of proof, is to write down the given information. So the given information was that angle ABD is congruent to angle BDC that was given to us, and then also given to us was angle ADB is congruent to angle DBC, and that was also given to us. So because our picture does not have any of the markings that we know that are given to us, let's just fill them in. So we're saying angle ABD, which is this angle right here, is congruent to BDC, which is this angle right there. And then the second pair of angles they're saying is ADB, which is this angle right here, is congruent to DBC, which is this angle up here. So one gets one slash mark and the other gets two so that we can differentiate which ones are congruent to what. And so from here now we have to think about our triangle congruences in order to prove that these two triangles are congruent. So when we were doing these, remember we said this line was congruent to itself. So if we write that in our statement, we're saying the line segment BD, so make sure you have the bar on top, is congruent to the line segment BD or itself. And remember the reason or the justification or why we can say these things is the reflexive property. So the reflexive property, and I said reflexive, which is not true, it's reflexive property, is the property that says something is congruent to itself. So that should be somewhere on your reference sheet, and we should know that one by now, that if something is congruent to itself, it's a reflexive property. So if we look back at our image, do we have enough information given one side is congruent and two pairs of angles are congruent in our two triangles? Yeah, we do. We know, and our reason for this, that these two triangles are going to be congruent is by angle side angle, because our side is sandwiched between those two angles. So that is the reason that we write it this way. So we can finally write our last step, which is triangle ADB is congruent to triangle CBD. And that is all we have for that example. So let's look at some more. So for example 2, pause the video whenever you need to and draw the picture and write down the given and proof statement. So, and also write down your two columns. So statement and reasons. Also, this is point D up here, just in case you were wondering. Alrighty, here we go. So our first statement, or whatever we start with for our statements, is always our given. So line segment AC bisects line segment BD, and that reason is because it was given to us. And we also know that angle B is congruent to angle D, and that was also given to us. So it's from here now that we need to fill in some information. So we said line segment AC bisects the line segment BD, which means that the line segment AC cuts line segment BD exactly in half, which means on my diagram I can draw that OD or DO is congruent to OB because AC cut BD exactly in half at the point O. So we know those two line segments are congruent. So that can be our third statement, is that line segment DO is congruent to line segment OB. And why do we know that? We just talked about how AC bisects BD. So we know that these two line segments are congruent by the definition of the word bisects. So that's our reason. We know that the definition of bisects means cuts exactly in half or makes two line segments congruent. So that's our reason. And we may not have used that before, but we can definitely use definitions for our reasons. Okay, what other information do we know about the diagram? We need to know, well, we've been given the information that angle B is congruent to angle D, and I just forgot to mark that. So we can mark that with one little tick mark on angle B and angle D because those two are congruent. And we also know that angle O on the left side and on the right side are congruent by vertical angles, right? So we can say that angle DOA is congruent to angle COB. And we know that by vertical angles being congruent are, I'm just going to write congruent signs so I don't have to write it all out. So do we have enough information now to determine if these two triangles are congruent? Yeah, we do. We have two corresponding or congruent corresponding angles and one congruent corresponding side. So we know by angle, side, angle that these two triangles are in fact congruent. So our last statement then is our proof statement, which is triangle DAO is congruent to triangle BCO. Okay, so for example 3, I got a little bit of a head start and wrote my two columns and my given statement. So why don't you pause the video and take a second to write all of this down. But now that we have the given statement that line segment AB is congruent to CB, which is marked for us already, AB is congruent to CB, then we also know that D is the midpoint of AC. And remember, midpoint by its definition means in the exact middle. So therefore, we can conclude that the line segment AD is congruent to the line segment DC, and we know that by the definition of a midpoint. So let's write that down. AD, line segment AD, is congruent to the line segment D, sorry, this is a D, DC, and we know that by the definition of midpoint, because a midpoint cuts a line segment exactly into two equal parts, just like a bisector. So now we have two corresponding congruent sides, and that's not enough information for us to prove that the two triangles are congruent. So what else do we know? We also know that DB is congruent to itself, the reflexive property, like we always do, right? So line segment DB is congruent to line segment DB by, our reason is the reflexive property. And then we have enough information now because we know our two triangles are congruent by the postulate side, side, side. We have three corresponding congruent pairs of sides. So our final statement then is triangle AB D is congruent to triangle CBD. Alrighty, last example. So take a second to write these things down. And I got a little bit of a jump start, so pause the video and take your time. So we have the given statements. Line segment AB is parallel to line segment CD, which is what these arrows are on this image. They're saying that these two line segments are parallel. And we also know that line segment AB is congruent to line segment CD. So from these two given statements, I can start making some conclusions about the diagram. Remember back in Unit 2 that we learned if we have two parallel lines cut by a transversal, and in this case, in our diagram, the transversal would be the line segment BC. So because of that, we also know that we can form some angle relationships, right? So I know that alternate interior angles are congruent, which are these two right here. So let's write that down. Angle ABC is congruent to angle CBD. And we know that, or our reason is, alternate interior angles are congruent. So by alternate interior angles theorem. All right, is that enough information? No, it's not. We only have two corresponding parts that are congruent, so we need a third part, and I'm sure you're going to guess what we're going to do, and we're going to do the reflexive property because BC is congruent to itself. So line segment BC is congruent to line segment BC, and we know that by, yet again, the reflexive property. If you wanted to just say prop, that's totally fine. And so now we have three corresponding congruent parts. We have a side, an angle, and a side. So that is our fifth reason to prove for our last statement that triangle ABC is congruent to triangle DCB. And that is all I have for you guys. And we will practice with these types of proofs in class. So hasta mañana.